بسم الله الرحمن الرحيم والصلاة والسلام على رسول الله رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Hello brothers, sisters, how are you? In today's lesson I would like to show you how we can model a warehouse in Tekla structure. And because of from many time I'm making videos on advanced steel, maybe you ask me which one is the best, Tekla structure or advanced steel. It's really a hard question to answer. There are some points advanced steel is better, some points Tekla structure is better. So during my videos, my series of videos, I will show you which one in advanced steel is better and which one is in Tekla structure is better. And it's my opinion. Maybe somebody has a different opinion, which is normal. And there are some cases. It depends which program you are using, how the project is big. Do you have big projects, small projects? What kind of projects you have? So it depends on the projects that you are working. I'm working from a while, from many times ago on advanced steel, but now I want to use a Tekla structure for some purposes, for huge projects. So you can use it whatever you want. Okay, so for making new projects in Tekla structure, here we have first of all we have to place in a folder. So I use this folder. I created this folder, EP course, this one, and I will select a folder, and from here I can name it let's say engineer Pshtewan model. So whatever you name it, it's no problem. So just click create. After that, if you look at the you have a 3D view, and we are just waiting for a while so it can create as a new project. So this here I have these windows here, Tekla structure, buttons, yeah. So we have this 3D view. If you go to any kind of grids, we cannot see it. If you go to view, I'll cancel this one. If we go to view, we don't have any kind of views except a 3D view. We will discuss about this later, no problem. Okay, so we have if you look at here, we have in X direction and in Y direction, just like this. Okay, so I'll just by double clicking here I can get this kind of grids, coordinates. As you see here, we have grids and elevations and everything. Here we can do it. Okay, so the first of all, I want to be in the X direction. I want to work in the X direction, so I will say at 0. This is the first one. At 0x0 I have a grid, and after that I will say 10,000, and I can see 2 times space 2 times 10,000. So it means that I have at 0 1 grid, after that 2 grids also. So I'll say modify. You see, A, B, C. So now in this direction I have 3 grids, one at 0 0 and the 2 others each 10 meters away from each other. Okay, so for Y direction, what I have let's say 7 times 6,000. So I have this one. If you look at here, I have only 1 2 3, the rest I don't have, so I have to add here 3 4 5 6 7 8 9 10 11 12. Look, I added more than one. Okay, so I'll say modify. As here it up to 10, up to 8. If I add another one, it will take number 9. Okay, that's the thing that we have. Okay, in Z direction, what we have let's say we have columns at 6 meters. Okay, and after that 1500. What we have, because it's a warehouse, so I want to be 1500 higher than the middle higher than the columns. And here again, here don't forget that these are labels. Okay, so I have to say the same numbers here. It's just identical. I can say first floor, whatever I want, but I will say +6 and +7. This one. Why I did this one? Because this is just a label. I will say modify, and I will see all the modifications here. Okay, so now if I go to make views from new views along grids, I want to all of these. I will say create. As you see here, if I go to any grid, for example number 1, I will bring it here, and you see what's this? Sorry. I did a mistake here. Here it's it should be 7,500, just like this. You see now, this one is good for us. Now everything is good. Okay, so I can name this one. I can name it. For example, I can say first floor, because it's just label. You see now it changed here. First floor, but I want to be just numbers, just like this, and modified. Okay, that's very good. In grids, for making grids, of course Tekla structure is much better than the advanced steel. Okay, I can control P to orbit around between 3D view and plan view, okay, for each grid, for the same grid, or I can control tab to navigate between open windows, which is from here. You can just see it from here. I have open 2 views, which I can navigate between by pressing Control and Tab on the keyboard. Control and Tab. Okay, so now I will go to this grid, which is grid A or grid 1, sorry, and I will go to steel, and I will go to make some columns, just like this. Just by clicking, it takes up to this point, and I'll say interrupt, right click, interrupt. You see here the dimension, the direction is good. The direction is good, and it's correct. It doesn't need to be rotated. If we rotate it, we can rotate it from here. And another thing in advanced in Tekla structure, I can just write down, for example, IP 300 and modify it. You see here also this one is better for in Tekla structure, and this one is named with the column, so we can identify that there's a column after making the connections. And the part number and assembly number, here we have C prefixes for these two, which is very good. And also we have the classes. We can put the colors if we want. So that's very good. The first one we did, and after that I will make a beam. And for making beam, I will take this this point. Okay, I'll take this point and go to the middle, and again I'll take this point and go to the midpoint. If I press Control Tab, I see that this one is quite so this is this is correct. So that's very good for us. Okay, this one is again is U and universal beam, so I will say IPE 300. As you see, look, if I write IPE, for example, this one, this number is not exist, so it's not exist in the library, so it doesn't give me modify. but while I put IP300, because this one is exist, so it gives me modify. Okay, just by clicking modify, it will modify this one. That's very good for me. Okay, so after that, what I'm doing, I'm just I want to make connections, but before connection, look, just by clicking on the grids, you see I have this magnetic on grid line. This now is no. So if I change the direction of this, for example, I have 2 at 2,000 instead of 10,000, let's say 12,000. Sorry. So you see, this one will not, this column will not go with that one. Okay, so I will go back and I will make magnetic on, and I will say yes and modified, and now I will come and change this one to 12,000. You see, this column now magnetic with the or attach it to this one or aligned with this grid. So I think this is a good point for here, for Tekla, which is this one is not exist in advanced seal. Okay, after that, what I'm doing, I want to make base plates, so I will go to the connections. I will say base plate. Because of integral structure, we have many components, so we have to know which one we select. Okay, which kind of stiffener for base plate, for example, this one or this simple one or this one. What kind of base plate we need? We can just by double clicking see the parameters of this one. Before using this one, there are many things that we can add and we can make. For example, this one, this more simpler than the others. We can use this one, for example, for like this project, or if we have a moment connection, we can use this one. As you see here, there are parts, there are things, whatever we have in connections. By my opinion, I see that the advanced steel is better and more clear than the Tekla structure. The connections, its connections, and more clear than the Tekla structure. However, connections in Tekla structure is more stronger than the advanced steel. Okay, so I will use this one, and I will click here for the insertion point. I want to look, pick a position. I want to add this position. And now, as you see here, it's just like this. By double clicking on it, there's no gap. It should be no gap between the base plate and here. We don't need any kind of, if we say 50, modify, you see that so delete this one. We don't have this gap between the column and the base plate. And let's say we want to be 20 at this side and 20 at this side and modified. Yes, if we have to select and modified. And if we say 50, let's try. You see, I don't know what is this. Really, to be honest with you, this is meaningless. While you put a base plate and you have this gap. Anyhow, I will say 0 and modified as it is. And for the thickness, I want to be 15 millimeters. As you see here, for the edge, you see, we add the edge. Now we say that 20 by 20, and we have this 30. So now this one became 34. If we say 600, let's try it. Modify. You see, now this one became 600, but here we put another thing. It should be as just like advanced steel. While you are playing with this one, this one changed as well with that one. So this is for 340 to be 20 by 20. If I leave it like this, it will live like this, because we put 20 by 20. What I mean, while we have 20 by 20, this one should be changed, or put a value of the length of the base plate, which I don't know why it's like this in Tekla structure. However, it's like this. So I think in connections, Tekla structure is more engineering than the Tekla structure. Okay, in advanced steel. So for the material, I want to I can click here, or I can write as 235 and modify it. The material is not in our catalog, so I will bring, of course, I'm sure that this one exists, but should be in as capital, modify. Okay. After that, I will go with the parameters, what we have, the bearing, and this one for the general. It's not we can, what we can do. We can leave some parameters. It's not a point that we have to put all the blank cells. No. We can go to anchor bolts. We have net profiles. This one I want to be, for example, like this, and to be like L shape, and I want to be the profile rod. I'll bring it, let's say D, and this D should be, let's say 24, and applied. Okay, and after that modified 24. So the net profile, I want to bring net profile metric M24 and modified. And for the washer plate, I want to bring washers metric M24 applied. Okay, and modified. Anyhow, so if we want extra plates, or we want to bolts, is here. The bolts, we can put the distances. Here is the number of the bolts. Here the distance. Maybe I want to two at distance of 150. I don't know if this works, or 100. Let's say. You see, now it's 100, and the other side I want to be 2 at 120, maybe, just like this. And these distances I want to be, for example, 40 at each side, and we see just like this. Okay, that's very good. The tolerances, I have the tolerance 2 millimeters modified, and this one 2 by 2. This is for slot holes. Anyhow, we need the bolt size. We have 24. The standard, what we have this one, yeah, modified. Okay, so I think now is good. Of course, we can, by double clicking, we can save this connection. Let's say EP base plate. We can save it. Save as, yeah, okay. And after that, I will click here. I will bring to the other side for the insertion point, until the same thing. This one, yeah. Now take the same thing, the same connection. Okay. After that, I will go with this hinge. So I will say hinge. For the hinge, we have the all of these hinges. We can use this one or this one or this one, but this one, by double clicking, we see that it has more parameters, so we can work with this one instead of others. Okay, so by clicking here, select the column, select the beam, as you see here. After the right click, interrupt, and we will change the parameters for this one. Anyhow, by double clicking, Look, by the way, you have to be sure that you are in here. Select component. If you select object in component, so you cannot use the whole connection. You can sorry, you can use one or select one by one the connection elements. Anyhow, but if you select this one and right click and go to properties, you can go to bring the properties for this entire or for example this one also properties. You can bring properties for this element. Anyhow, but when we here you are here and select it and right click properties, it will bring you the properties of the connection. Anyhow, so we see the first of all the picture that we have in this shape, or we have in this shape horizontal rafter double hinge. Horizontal rafter double hinge. What we can select this one, which we don't have at the upper side, yeah, but I think this one is good for us, or this one, whatever. And after that I will go to parameters. This is the end plate. The end plate thickness is 15 millimeters. You see, I will change one by one, and I will click modify to see which one is that. This is the stiffener, and we have top plates, we have hunches. Here we have hunch. The hunch profile, I can see IPE 300 modified, and the hunch length. You see, look, for the hunch length is what I want to put. I can put S1, I can put L1, I can put L2. So I think L1 is good. However, it can be this one. We can make it simpler just by making this one L1. Why all of these L's exist in this connection? So I will go with L1, and L1 I want to be 1200 modified, just like this, and I want to use H2. Again, I want to be, for example, 300. We see now H2 and this one. Now we have these two parameters here. Okay, so I'll go back to the parameters. Add the stiffener, compression stiffener. As you see here, we have this kind of stiffeners. At the top we don't need, at the middle we don't need, at the bottom we don't need as well, so modified. So we don't have any kind of stiffeners here. If we have stiffener, we have to select for this one, for example, this stiffener we have. You see, now you have this cap plate with the stiffener. As you see here, we have. And as you see here, a distance. Well, what we have this distance. How much we want to be higher. Let's say 330. You see, now the column is higher than this one by 30. So I'll delete it. I don't want to be this one, and I don't want any kind of stiffener here. I'll modify it. Anyhow, and you see here now is this one is the horizontal, and what I can do, yeah, this one is very good for me. And if you look at this hunch with this beam with the column is at the same line. Anyhow, after that I can add whatever cap plate. I can say that I have a cap plate 10 millimeter, but while I have a cap plate, okay, I'll delete this one first. We say, for example, this one. No, it is. which one we select? Yeah, we select this one, modify, but we have to select the connection also. Here, look, cap plate, let's say 50. This no stop plate, not cap plate. Delete it. And this one 50. Why I put these numbers to just to identify the plate. Okay, I don't want this one, so I'll delete it. And of course I will say I have no stiffeners here. Okay, after that I will go to general. As I said that we don't need to change the other parameters. Here we have material, we can say S235 and modified. And as you see in the general and hanch, we set the hanch. I think doesn't need look, we can look at like this. Here the hanch is here. If we go to the side, the hanch is like this. If we want, we can use it just like yeah, this one. Yeah, we can use it like this, modified just like this. At the other side as well, we can use whatever we have. I think this one is pretty good, so it doesn't need to make it. Yeah, from here we can just make it like this to be attached to this point, but I think it doesn't need. This one will be filled by a weld later. Anyhow, so we have this one, and for the extra plates, if we want to extra plates and things like this, you see, we don't need chamfers, holes, we don't need. We will go back, go to bolts directly. We have to pass the first one, the beam pass, and this one the hatch part. I will select M24, the standard I'm using. This one, and the tolerance I want to use 2 millimeters. So I want to 3 bolts at 60 maybe, or 80. I can modify it just like this, and from here what I want to be this one at 60. From this point to that point, 60, modify. I think it should be more than 60, should be, let's say, 100. Modified, just like this, yeah. And this one, we wanted 2 bolts at, let's say, 100, if it's good. Or maybe 120. Yeah. As see, just like this. And now I think it's very good for us. And this one too at 80 maybe. Modified, modified, just like this. You see now, it's very good. M24 and very good. As well, we can save as a standard or whatever name we want. After that, I will go back to hanch, this one, select this column into that one, and now as here we have the same thing. Okay. After that, what we have this one, this kind of connection, and again the same thing. I can double click on it. If I want to more than, let's say we have 10, modified, and what we have 1000, let's 1000, and here 1000, modify, and modify is here, and from the center to that one, from the center of this beam to that one, let's say we have 300 or 400, whatever we have, 400, whatever, as I said, whatever we have. So we can put, by pressing V and clicking here, we can orbit around up to this point, the selecting point. Okay, and after that go to parts, the end plate I want to be 15 millimeter modified, just like this. After that, the hinge profile, I want to add the hinge profile, so I will say IPE 300, just like the beam, and modified. Yeah, if I select instead of 200 300 200 modified, you see now this one modified, but I have what I have 300, and click modify. Okay, after that we have other parameters. If we want like these or this, we want to be vertical, and after that go to bolts. The default size is 24, let's say. The standard is the same standard. The tolerance is 2 millimeter, and modified. Here we have, if you look at this one, what we have, again this one, let's say we have 60, modify. Now you see, and this one we have at 100, but we have 4 at what time 100, or maybe 5. Yeah, I think it's good now. Right now it's good, and this or this one too at 80, modified again. 2 bolts at 80, and this one, let's say 40. Now this one is a nice connection, and we don't have any problem with that one. After that we can go to a modify. Okay, and by this we could use this, or we reach up to this point, we make it a frame, and after that we will copy this frame to the other grids. So this for the first for this lesson. For the next lesson I will copy these frames and make other required elements. Thank you very much.